Right. This is again related to configuring BGP. Those who have not done the previous lab, it's okay. But after this class, you have to do the same lab. Those who have done, I appreciate. And you have already understood. While doing it, definitely there may be some learning. Through that learning, you might have understood what I'm going to teach you now. So, good. Let's go inside this chapter and see what are the considerations that we have when you configure BGP. You know, this one is the very first command that we type to enable BGP. Router, BGP, and then a number. An autonomous system number. This number uniquely identifies your office, your organization, your enterprises. Now, who provides this number? Your upstream ISP, meaning the ISP to which you connect, your organization connect. They will give you this number. You need not to decide a number. They will give you. But in our lab environment, we will simply use 10, 20, 30. It's okay. Even in this autonomous system, there's a private range which is used for a concept called confederation. But nowadays, confederation is not in use. So it's okay. But anyhow, this number, you don't need to worry. You'll be getting it from your upstream ISP. Now, router BGP autonomous system, let's say 10. What does that mean? It means that this router belongs to the group called 10. Your neighbor company may be autonomous system 20. So, to identify the routers of the company, we put all our routers in same number to form an autonomous system group. We learned earlier, autonomous system is group of routers or any BGP appliance that are under single technical control, single technical policy, single technical administration. That is what autonomous system. Right. So when you type this command, the router enters into a BGP configuration mode. And then there are a lot of other commands that we need to enable to activate a BGP peer. So this alone will not run BGP on all interface. This is just entering into BGP router mode. After getting into the mode, it's our duty to say who our neighbor is. The neighbors need to be manually configured. Only then BGP gets activated towards the neighbor. And you cannot run more than one BGP. If I say router BGP 10 on one router, I cannot say another BGP, router BGP 20. Not possible. Any one BGP. Only one BGP in one router. You cannot have more than one BGP. Only one instance of BGP can be configured on the router at the single time. Next, the autonomous system number identifies the autonomous system to which the router belongs. I already said, if I say router BGP 10, it means this router belongs to autonomous system 10. The autonomous system number is in the command. The autonomous system number in this command is compared. Okay, this is something important to understand. This point is important to understand. Listen, when I say router BGP 10, router BGP 10, I'll be inside router mode. Right, I'll be inside the router mode. Now I will say what? Neighbor. Let's say 1.1.1.1. I don't have a space, so I'm writing in the next line. Remote AS. This is the command I used the other day. When I say remote AS 10, this autonomous system in this router BGP command is compared with the autonomous system number in the neighbor statement. If the number is same, what does that mean? Someone answer.
IBGP.
IBGP, internal. If it is different, then it is EBGP, external. That's what this command and this line says. The autonomous system number in this command is compared to the autonomous system number listed in the neighbor statement to determine what? Whether the neighbor is an internal neighbor or an external neighbor. Hope you understand this statement. If you have a question, you may ask.
Yes, sir.
Right. Now this is the neighbor statement, which I just wrote in the previous page. Neighbor's IP address, and then remote AS autonomous system number to which the neighbor belongs to. We'll talk about the peer group a bit later. Peer group is also to identify neighbor, but it is not single neighbor, it is group of neighbor. See, what is the meaning of peer? Peer is the other word for neighbor. Yeah? Neighbor group, peer group. If I have only one neighbor, I give the neighbor's IP address here. If I have collection of neighbors in the same autonomous system, then I need to say peer group, neighbor group. We'll talk about how to group the neighbor later by using a template. Now, the neighbor command is the one which activates a BGP session with the neighbor. That's why in the previous slide it was said this command is just entering into the configuration mode only. It is not really going to activate any BGP session. See, we must enter into subcommand. What is the subcommand? This is what the subcommand is. We need to enter into the neighbor statement and say, I want to form neighbor with this guy. I want to activate BGP session with this person, 1111. The IP address that is specified is the IP address that is specified is the destination address of all the BGP packet going to the neighbor. What does this mean? Let's say we got two routers. 10.0.0.1, 10.0.0.2. They may be in different autonomous system or same autonomous system, that doesn't matter. Let's say they are in different autonomous system. Autonomous system 10, 20. Now I go to this router 1 and say neighbor 10.0.0.2. So what will happen? As soon as you say this, BGP in router 1 will generate a packet like this. It will generate a packet like this. A TCP three-way handshake is what the first thing that it will try to do. With the source address of the egress interface. This is what egress interface going out towards router 2. With the egress interface IP address 10.0.0.1 and with the neighbor IP address, this one 10.0.0.2, packet will be generated. And this packet will now go to router 2. That is what this statement explains. Listen, second point. The IP address that is specified is the destination address. Is it not true? Look at this. The neighbor statement has got 10.0.0.2. That has become the destination address of the packet going to the neighbor. And This router must have a IP path to reach. Yes, this need to be pingable. These two addresses should be pingable. Of course, it is pinging because they are directly connected. Can BGP form neighbor with a remote router? Yes. Make sure there is an IP path. We have seen this, we will see it again later. Now this router must have an IP path to reach this neighbor. So to form BGP relationship, before forming the BGP relationship, it checks that connectivity, it checks that IP path by sending TCP packet. If three-way handshake is successful, only then BGP packets will be sent, which means it first establishes connection. Establishing connection is possible only if you have IP path. This is an application layer protocol. Listen, this is the important term. BGP is an application layer protocol. Layer 7 protocol. What about Telnet? Why I am comparing with Telnet? Telnet is also using TCP. Telnet is identified with the number 23, TCP 23. BGP number is TCP 179. So both are application layer protocol. They first do three-way handshake, establishes a connection by sending SYN packet and SYN acknowledgement. So when you receive acknowledgement, which means there is an IP path, now you can send BGP packets. Now see the third point. This router must have an IP path to reach this neighbor before it can set up a BGP relationship. So first of all, before BGP relationship, what is necessary is the IP path. Now the remote AS option shows what AS the neighbor is in. The remote AS shows in what AS the neighbor is in. The AS number is used to determine if the neighbor is an internal or external. It's the same point that which we saw in the previous slide. Yeah, the remote AS, the number that we type after typing remote AS option shows the neighbor in which autonomous system he belongs to. If the neighbor autonomous system and our autonomous system is different, then the neighbor is an eBGP neighbor. If it is same, the neighbor is an iBGP neighbor. That's what it says. You see, the remote option shows what AS the neighbor is in. This AS number is used to determine if the neighbor is an internal or external. And see the last point. This command is used for both external as well as internal. See, remote, the word remote sounds like external only, but it is not true. In BGP, external or internal is determined by comparing the autonomous system number, not the command. This command remote AS is just a keyword which is used for both internal neighbor as well as external neighbor. Because of the word remote, you should not misunderstand that the neighbor is external. No. If the autonomous system number is same, the neighbor may be internal also. I'll show you example. You see here. This is the local autonomous system to which A belongs to. And this is a neighbor 10222, which is here, which is in the same autonomous system. Same autonomous system. But the keyword you see, it is used as remote. So because of this word remote, I should not take it as external. It is not external. Because the local and the neighbor autonomous system matches. It's internal. When this don't match, you see, 192.168.1.1, which is the other autonomous system, It don't match here, which means it's an ABGP neighbor. Same command remote AS is used for both internal and external. So remote AS is just a keyword. We need to only focus on the number, autonomous system number. If this number matches the router BGP autonomous system number, then it is the internal. If it is not matching, then it is external. Question, please. All right.
So there was one time I saw the greater than sign with the asterisk. What do those?
When you have greater than sign with the asterisk in the show IP BGP command, with greater than sign is the best path. Without greater than sign is not best. It's not elected. More deeper knowledge on the greater than sign I'll be teaching you as we move further. But as of now, in short, what I want to say is asterisk with greater than symbol path is the elected path. If you have only have the star and there is no greater than symbol, then it's a BGP given update but not in use. If you don't have greater than symbol, then those routes are not in use but given by BGP.
Thank you, sir.
Welcome. Now here we go. The next page says if you want to temporarily shut down a neighbor, see, after configuring neighbor like this, for some reason you want to temporarily shut down, so you can simply shut down. You no need to remove this statement, keep this statement. You can simply type another command, neighbor 192.168.1.1 shut down. So the neighbor is configured, but it is not going to be active now because you have said shut down. So there won't be any three-way handshake sent anymore. BGP neighbor is terminated. BGP is not going to be active for that neighbor. To unshut, you just go to the front and say no neighbor shut down. So this will come up, right? So you no need to cancel the configuration that you did. You may temporarily just use the keyword shutdown, and to bring it up, say no shutdown. So administratively bringing down a BGP neighbor is by using shutdown. Used for maintenance and policy change to prevent route flapping. So you no need to remove completely all the configuration. Whenever you want to do some policy change for a neighbor and redo it, you no need to redo everything from the beginning by removing the neighbor. You can shut down the neighbor, do the necessary policy changes that you want for the neighbor. More knowledge on what is the policy change, what sort of maintenance, you will come to know as we start learning attributes. So now this may be half understood. It's okay. Now it's okay. Used for maintenance and policy change to prevent route flapping. So you no need to remove the neighbor which will flap. Instead, you can prevent the route flapping by just shutting down and do all the necessary policy changes for the neighbor and bring it up by saying no shutdown like this. No neighbor. So re-enable BGP neighbor that has been administratively shut down by putting this no in front of this command. See, when do we use this shutdown command? I do not want to remove neighbor. I just want to change some policies for the neighbor. So what I can do is I can shut down and do the changes and then type no to unshut. Now we are entering into... yes, please.
Right. It's necessary to shut it down if you're going to make changes to the neighbors.
It would be good if you do this, or there is another command, reset neighbor, but for which the route flapping will happen. We call it as clearing BGP session. Without flapping also there is another option, clear BGP soft command. We call it as BGP reset. It must be coming in the same chapter in the end. We'll see that. But again, I'm telling you, this shutdown, I've not seen many people using it. We use another command called clear IPBGP star soft. So if you feel like doing this, you can use it, but first of all you do 2-3 times and test in your lab environment, and when you're convinced with the topology change, the impact, then you may go with this option, but not many uses this option. Most of the people use clear IPBGP soft, which comes later. Whenever we do some changes to the policy, instead of shutting down and unshutting down, we just simply refresh or resend all the BGP policies one more time. Instead of removing the neighbor, or instead of shutting down the neighbor, whenever we do the changes in policy, we resend the policy. We send it again with the newer policy. We send the newer policy to the neighbor, so the neighbor will get updated. We resend it with the new policies. That is how we do in the real world, by using this command, clear IPBGP star soft, or clear BGP IP address followed by soft. Yes, sir. Question? So may I have a question?
No, that was all. Thank you.
Okay, right. You're welcome. Now, listen, this is important. Whatever you read here may be like just an information for you, but it will show how much it is important in the next 2 or 3 slides. Here if you just read and go, oh okay, fine, and then you will forget. But when you see the next 2 slides, then you will understand why this page is very important. Let me read first for you. BGP issues with source IP address. That's the main story here. Source IP address. I told you, listen, when I have 2 routers like this, and this is 10.0.0.1, 10.0.0.2. Here I have said neighbor 10.0.0.2. Here I have said neighbor 10.0.0.1. What I told you is, when you do like this, from router A, the source address will be the exit interface address. This is the exit interface address, 10.0.0.1. We are dealing with source IP address. What will be the destination address? 10.0.0.2. Now, when this packet goes to router 2, what router B will do, Router B will check whether, focus, router B will check whether this neighbor address is matching with the incoming source. Only if it matches, or if the incoming source address matches with any of the neighbor statement, only then B will show interest in talking to the neighbor. Otherwise B will say, okay, you are running BGP, fine, so what? BGP will not entertain the packet. Because you got an address 10.0.0.1, when this packet comes here, router B will say, wow, thank you, I was waiting for you. How are you? Very fine. I'm very happy to see you here. Router B will be very happy. But what if I don't have this? And this packet will come here. Let's say I put wrong address here. Instead of neighbor 10.0.0.1, I put wrong address. Accidentally, I have put 10.0.0.10. 10.0.0.10. When router B receives 10.0.0.1, router B will say, okay, 10.0.0.1, fine, thanks for coming. I'm not interested in you because I don't know you as a neighbor. For me, I have only 10.0.0.10 as a neighbor. I can only have relationship with 10.0.0.10. But you are 10.0.0.1. Sorry, I don't know you. You see? If match is not found, the packet is ignored. If match is found, relationship is established. If the source address, see, when the packet is received for a new BGP session, the source address of the packet is compared to the list of neighbor statement. See, here is the neighbor statement. B is comparing it with the neighbor statement. But neighbor statement is not having 10.0.0.1, which is seen in the source of the incoming packet. If match is not seen, packet is ignored. If match is found, the relationship is established. So, we need to make sure that the source IP address matches the address on the other router that has in the neighbor statement, meaning you need to make sure this is not 10, this should be 1. You need to make sure the source address of the incoming packet is seen in the neighbor statement. Right, let's read from the beginning, the first line. When creating a BGP packet, the neighbor statement defines the destination. Is it not true? Yeah. Neighbor statement determines the destination. And the outbound interface defines the source address. Is it not true? Yes, it is. So, when a BGP packet is received on the newer BGP session, means router B, when router B receives this packet for a newer BGP session, the source address of the packet is compared with the list of neighbor statement. If match is found, relationship established. If match is not found, the packet is ignored. So make sure the source address of the incoming packet matches with the router B's neighbor statement. Any question?
Sir, I have one. Sir, destination, the first statement, neighbor statement defines the destination IP address. I got it. But and the outbound interface, we never give neighbor statement outbound interface, sir.
See, for router A to go to router B, for router A to go to router B, will it go this direction? Answer me, please.
Yes, sir.
Will it go this direction? What? Yes. See properly. Yes. What? Will it go this direction?
No. The red one.
It will go this direction, right? So this is the outbound. This is not outbound. This is the outbound.
So basically that IP address 10.0.0
it will check the routing table. It will check the routing table. The neighbor statement says 10. 10 is in this direction. This is the outbound, not this direction.
Okay.
So the routing table will show you those things. That's why it is router. Router will show you the direction which is outbound and which is inbound. Yeah. Now, outbound interface IP address will become the source address. This is dynamic. You no need to say BGP, use this address as the source. No, you don't say that. You might have said that in GRE tunnel, when you form GRE, or in some other places. But here you no need to say the source address. Source address is dynamically picked up looking into the routing table in order to go 10.0.0.2, the outbound interface will be, let's say, F00. The routing table will say, find that address on that interface will be taken as the source address automatically. All right. Any other question? All right. Now, this is another story, but the story is also related to this page. Whatever you have heard me speaking on this page, it might have sounded like an information for you. If match is found, relationship is established. If match is not found, the packets are ignored. It sounded like, okay, fine, good information about BGP, but it has got something more to teach us. So let's see an example here. How many routers you see here? Answer please, everyone. How many routers you see? 4 routers. Now, for A to reach D, how many paths are there?
3.
Please see carefully and say. For A to reach D, how many physical path you see?
2.
2 paths. Right. Now, if I'll go to router A and say neighbor 10.2.2.4, if I say neighbor 10.2.2.4, if this link goes down, what will happen to the neighbor? Neighbor will break. Because when the link goes down, this address will go down. If I say 10.4.4.4, this one, if this link goes down, I lose the neighbor. So what is the best way to form neighbor when we have redundant path? When we have redundant path, what will be the best address to form neighbor? Loopback. When you go to router A and form neighbor with router D using its router D's address, likewise router D will use 1111 to form neighbor with A. There's a big advantage. What is that? If this path goes down, these networks may disappear, but still you will have neighbor because your neighbor is 11111, which is reachable via this path. So we have to use loopback interface IP address. The IP address of the loopback interface as a neighbor to form peering instead of the physical interface address whenever we got a redundant paths. This is the best option. Use the loopback interface to form neighbor whenever we have redundant path. Are you convinced with what I said? We need to use the loopback interface, not the physical interface, because if the link goes down, the neighbor will go down. But if I have a loopback interface, even if any one path is available out of these two, I'll have the neighbor. Are you convinced with this?
Yes, sir.
Right. Now comes the issue. What is the issue? Here comes the issue. What is the issue? Listen carefully. On router A, what is the neighbor we have said? Answer me, please. What is the neighbor address we have said? No, you want no, you tell me the address now.
4.4.4.
Very nice. 4.4.4.4. On D, what is the neighbor we say?
111.
All right. Now, let's go back to the previous page and then come back again here. In the previous page, we learned when a packet is the first point. When creating a BGP packet, the neighbor statement defines the destination. Okay. So when A creates a BGP packet, what will be the destination address? The address that you specified in the neighbor statement. Agreed? Yes or no?
Yes.
Yes. Same way. In D, when D creates a BGP packet, what will be the destination address? 1.1.1.1. Wonderful. Now going back to the previous page. Listen. When creating a BGP packet, the neighbor statement defines the destination and the outbound interface is the problem here. Outbound interface defines the source. Listen. To reach 4444, this may be an outbound interface or this may be an outbound interface. Agree? Yes or no?
Yes.
Yeah. Let's say this is the outbound interface. Then what will be the source address? 10.1.1.1. If this is the outbound interface here, what will be the source address? Answer.
10.4.
10.2.2.4. Okay. Now, this is the BGP packet now. You see, this statement says, second statement says, when a packet is received, now let us go and receive. This packet is now received on router D. When a packet is received, the BGP source address of the packet is compared to the list of neighbor statement. Meaning, this address is compared with the neighbor statement. Is it matching? Is the source address matching with the neighbor statement? Answer me, please.
No.
Not at all.
No.
The source address is not matching with the neighbor statement. If it is not matching, see, if no match is found, what will happen? The packet will be ignored. The packet will be ignored. The neighbor will not be established. You understood the problem?
Yes.
That's why the last point says you need to make sure the source address always matches with the remote router's neighbor statement. So we need to do some magic here. Listen carefully. We need to do something so that I still use the loopback. I don't want to change this. The neighbor statement needs loopback because we got redundant path. But I need to do something here so that my source address won't be the exit interface address. The source address will not be dynamically picked by the router with one of this physical exit interface. Instead, my source address will be the loopback interface address. So if I will change if I'll put some command and tell BGP, listen, if I put some command in router A and tell BGP, let your source address be the address that is found in loopback 0. If I say that, then the source address will be 1.1.1.1 instead of the exit interface address, instead of the egress interface address. So I have an option called update source command. There is a command called update source. Whenever you speak to 4.4.4.4, use the update source, meaning send all the update sourcing using the loopback address, loopback 0. When you say this source address will not be exit interface address, it will be the loopback interface IP address. Now if the packet goes, is it matching with the neighbor statement? Is the source address matching with the neighbor statement? Answer me.
Yes.
Yes, it matches. If it matches, the neighbor is established. You see, if match is found, the relationship is established. Likewise, in router 4 also, router D also, I need to say, use the neighbor whenever you speak to 1.1.1.1. Use the loopback 0 as the update source. Yeah. When you put these commands correctly, the source address will become not the exit interface address. Instead, it will become the address which the other remote router will accept. Did you understand the meaning of the command update source? I was using this command in the... No, I didn't use. Did I use? Yes, I did use. Okay. But again, I'll be doing this lab. Again, I'll be demonstrating this update source loopback sources 4.4.4.4. Yeah, when you say loopback 0 interface, this address will be copied as a source address and they will form neighbor. So when this packet goes here, see it is matching with the neighbor statement. The source address matches. That is what explained in the next page. Look at this update source command. This is the command. In order to change the source address to match with the remote router's neighbor statement, we use this command neighbor. I just use that command. Neighbor's IP address, update source, loopback 0, something like that. And this command allows the BGP process to use the IP address of the specific interface, not simply an egress interface, specific interface as the source IP address of all BGP updates to the neighbor. The loopback interface is what usually used, which I showed you, because it is available as long as the router is operational, meaning even if one of the path goes down, there is another path. Loopback will be always available because it's a logical interface. The IP address used in the neighbor command on the other router will be the destination IP address, and all BGP updates should be sourced with the loopback interface, which we learned. Neighbor update source command is normally used only with IBGP neighbor. Yes, very important. It doesn't mean that we cannot use with eBGP, but normally, generally, mostly, popularly, it is used only between IBGP neighbor. The address of the eBGP neighbor must be directly connected. That's the reason. If you are using loopback to loopback, they are not directly connected. For eBGP, the neighbor needs to be directly connected. We learned in the previous class. eBGP neighbor must be directly connected by default. IBGP neighbors need not to be directly connected. So, for this reason, we don't use loopback to loopback peering between eBGP. We peer using the directly connected IP address. But if you are using loopback to loopback in eBGP scenario, then also there are a lot of tuning need to be done, but it is possible. It's not that not possible. It is possible, but here it says generally, normally we don't use loopback. Normally we don't use loopback to loopback peering between eBGP. So this command may not be needed for you if you are doing eBGP, but needed for IBGP. Here is one example. Please focus. Router B. Router B and C has got, you see, redundant connection. 1, 2, redundant connection. So we will be forming neighbor using loopback address. See, 3333. In this router we are saying 2222. But we need to source it with the loopback interface. So we say update source. Whenever you speak to 3333, use the loopback 0. So that the source address will not be 1011 or 1022. It will be only 22222 and 33333. Any question?
So, why would we need OSPF? I mean, would it need OSPF to work full mesh?
See, for this to work, we need OSPF or EIGRP or any routing protocols here. They are running EIGRP. Why, you know? When you are sourcing your packet now BGP is going to send packet. Sourcing with 2.2.2.2. Destination will be the neighbor address. What is the neighbor address? 3.3.3.3. If you don't run OSPF, B will not know where is 333. How B can ping 333? You tell me. How this packet can be forwarded? Router B will not know about this loopback of router C. Yes or no? Will not know. Correct?
Right.
Yeah. So for B to know the location of 333, the direction of 333, to route the packet to 333, there should be an IP path. That's what I explained some time earlier. IP path. Look at this point. This router must have an IP path to the neighbor address. So when you are saying neighbor as your loopback address, when you are saying your neighbor address is 3333, there should be an IP path for B. B should know how to reach 33333. For that you need some protocol to advertise 33333. That's why we use OSPF or EIGRP. Now once you know the route, then BGP can use the route to negotiate and form BGP neighbor. Again, there may be slight confusion again for you in your mind. Like, come on, what is this? You are already running OSPF. Then why you need BGP? Answer, I am repeating again. Long time back I told you this. OSPF is just for giving route information for the inside networks. BGP is giving route information for outside network that is coming in and going out. So BGP has got its own job, only takes care of those external network using this BGP peering that you are forming now. OSPF is taking care of the internal network. They both don't have the same business, though they are same family routing protocol. This does the father job, this does the mother job. OSPF takes care of the family, mother job. Taking care of family is what? The role of women in the family. Taking care of the financial needs and supporting protection is what? External, all the stuff is what? The husband's role, which is taken care by BGP. Both are needed for a family, husband and wife. BGP is also needed, OSPF is also needed. Hope it is clear now.
Yes, sir. Because I remember I was trying to ping, let's say in this picture, 172.16.1.1 to 192.168.1. It won't ping. Only thing that works is a trace.
We'll talk about that pinging between A to D later. Whatever the concept that we have covered today, is that clear for you?
Yes, sir.
Okay.
Sir, yeah. Sir, one thing, sir, can you just, one more time, make in the next class, can you please explain one more time that the routes should be in the IGP table before coming to the BGP table?
No, I did not say that.
Means, as you said, sir, we have to run OSPF.
That is for neighbor reachability. The neighbor address, you see, router B, you say neighbor is 33333. Yes or no?
Yes.
Answer.
Yes.
Now,
even the static route also I can do that.
That also you can do. Anything. You need to have a route, that's all.
Okay.
Alright, fine then, we'll stop.